Good morning, my dear students. Welcome to NALLA NARSHIMA REDDY Education Society's group of institutions, integrated campus, structural engineering, reinforced concrete. I'm Dr. A. Mahesh Babu, Professor, Department of Civil Engineering. Last class, we discussed about different types of structures. Today we will see tall structures according to height, skyscrapers. Normally, structures height between 3 meters to 36 meters, normal structures. They are called as normal structures, 36 meters height. Generally, one floor is 3 meters. So approximately, how many floors will be there? 12. So 1 to 12. For 3 meters, 1 floor. Okay. Similarly, for 36, 12 floors. Similarly, after normal structures, we'll see high-rise structures. Height between 37 meters to 75 meters. Number of stories 12 to 25. Similarly, skyscrapers more than 75 meters. Skyscrapers. Here we will see some more of skyscrapers. This is a Kingdom Tower, 1000 meters height. See, in Dubai, it is more than around 850. Your World Financial Center, 492 meters. Here, 484 in Hong Kong, 437 Dubai. These are some of the high-rise buildings, skyscrapers. See, we will see one small video regarding tall structures. Observe it. See how they designed for loads. Just watch.
These are the tallest skyscrapers ever constructed. But while these structures may inspire awe, many of them have achieved their record-breaking status by using one of architecture's most controversial tricks, vanity height. The term is officially defined as the difference between a skyscraper's highest usable floor and its pinnacle, and the global ranking of the world's 10 tallest buildings would undergo a pretty serious shake-up if it didn't count. The early 20th century saw many tall buildings include vanity height, partly as a result of the Art Deco style popular at the time. However, as architectural trends moved on, we saw the emergence of skyscrapers that did away with vanity height in order to maximize floor space. Controversy seemingly first erupted in 1998 when Chicago's Willis Tower lost the title of world's tallest building to Kuala Lumpur's Petronas Towers. Despite their roof lines sitting some 63 meters lower than the Willis Tower, the Petronas Tower's decorative spires were included in their official height. The owners of the Willis Tower argued that if minor additions like these slender pinnacles can be included, then the substantial antenna on their structure should certainly be counted. This led the Council on Tall Buildings and Urban Habitat to deliver a ruling on what it considers part of a building's overall height. The ruling excluded anything that could be arbitrarily increased in height, such as communication antenna, but allowed for the inclusion of decorative spires, as long as they formed part of the building's original design and did not exceed 50% of the structure's overall height. Since then, the heights of several tall buildings have been called into question by professionals and the public alike, with many architects and developers using pre-designed vanity height to inflate their projects for prestige and to lay claim to various tallest titles around the world. Nowhere is this more evident than in Dubai, a city which has spent the last 30 years in the midst of an unprecedented construction boom, and that is now home to some of the tallest structures on Earth. Striving to make its mark on the world stage, vanity height has become a prolific part of the city's development, and Dubai now holds the title of world's vainest skyline. The city's 19 tallest skyscrapers owe, on average, 1/5 of their overall heights to unusable space. Indeed, the world's current tallest building, the Burj Khalifa, officially stands 828 meters tall, but 244 meters of that is made up of unusable spire. Some 29% of the building exists purely to increase its height. The nearby Burj Al Arab became the tallest hotel in the world when it first opened in 1999, claiming the title by way of a 124-meter spire.
See, these structures, designs, models given by architects, but structural engineers will design these structures. They have to take care of safety, economical, they have to take care of all loads. So really it's very interesting and very tough job to design according to architect. That is one of the important.
Made up 39% of its height. This trend and its ensuing controversy is by no means limited to emerging Asian and Middle Eastern markets. In the United States, One World Trade Center officially became the third tallest building in the world when it completed in 2014, and has only fallen 3 places in the global ranking since, despite appearing dwarfed by several other, more recent skyscrapers. Over on the West Coast, Los Angeles' US Bank Tower was overtaken by the Wilshire Grand as the tallest building in the city in 2017, despite Wilshire's roofline sitting 26 meters lower. Australia's tallest building, Q1 on the Gold Coast, has held the title since 2005, despite skyscrapers in Sydney, Melbourne and Brisbane, all rising far beyond Q1's 235-metre highest usable floor. Meanwhile, the Varso Tower will bring the title of Europe's tallest skyscraper outside of Russia to Warsaw in 2020, thanks to an 80-metre spire that has been included in the building's overall height. More recently, the Council on Tall Buildings and Urban Habitat has sought to ease tensions by developing 3 separate rankings for tall buildings: height to architectural top, height to highest floor, and height to tip. Despite this, the debate about where to draw the line when we measure tall buildings rumbles on. Controversy is set to heat up again in 2021 as the 644-metre Merdeka PNB 118 in Kuala Lumpur becomes the world's second tallest building, bumping China's Shanghai Tower into 3rd place. So where do you draw the line when measuring skyscrapers? Let us know in the comments below. And as always, if you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1 app.
I think you enjoyed this video. You understand high-rise buildings, how to design. That is very important. Rigid frame. Again, this is a type of frames, different types of frames, including beams, columns, grid bridges, arches. This is also one of the structure. You see, this is one of the RCC structure with the different components. This reinforcement. See, in coming chapters, you will understand why we are providing reinforcement more at the bottom. You will see different components, footings, plinth beam, columns, beams. Stirrups, these are stirrups. These are crank bars. Slab. These are covers under the reinforcement. You see how the reinforcement placed on the slab. Alternative crank bars. Observe carefully. This is slab with the cantilever slab. In cantilever slab, you will have more reinforcement.